Okay, question 2a. So we still have an equilateral triangle. So all the side lengths are supposed to be exactly the same. Now, this time we are looking at rotational symmetry. So we really just try to rotate this shape at its center. So let's say I rotate this corner. I can rotate until it fits until this first corner becomes at the location of the second corner, right? Maybe I'll just call that A and B. So I can do that one more time to C, and then now I'm back to A. So every time when it fits perfectly back onto itself, that will be accounted as one rotational symmetry. So here I can do it 3 times, so there are 3 rotational symmetry. And the question is asking what is the smallest angle of rotation each figure has that keeps its rotational symmetry? Well, the smallest angle, because in one complete rotation is 360 degrees, and we are able to do it 3 times, so the smallest angle is going to be 120 degrees. And this 120 degree has a special name. It's called the angle of rotation. Okay, so the answer will just be 120 degree. B. If you look at the square, you should be able to do it 4 times. You rotate it around its center so it fits perfectly back onto itself. So the smallest angle of rotation is going to be 90 degree. C for the rectangle. So that's the center of rotation. If you rotate it, the first time that it will fit back onto itself is going to be at C. And then if you rotate it one more time, it will be back to A. So you can only really do it 2 times. So the smallest angle of rotation is going to be 180. So you might see a pattern already. It's very similar to the previous question for reflection line of symmetry. 3-sided regular polygon, you'll be able to rotate it 3 times. You have 3 rotational symmetry. 4-sided, you'll have 4 rotational symmetry. So using that pattern in D, because this is a 6-sided, the smallest angle of rotation will just be 360 divided by 6, and we get 60. E is 5-sided, so 360 divided by 5, we get 72. F is not a regular polygon, so we cannot use that pattern. We just have a parallelogram. So this is the center. If you rotate it, it will fit perfectly back onto itself when the A reaches C. So you can just do it 2 times. So the angle of rotation, or the smallest angle of rotation here, is 360 divided by 2, and we get 180 degree. G is a regular polygon. We can use that pattern. It will be 360 divided by 8 because it's 8-sided. So we get 45. And then H is n-sided, so it will just be 360 over n degree. That's the answer. Okay, so that's question 2. I'll see you in the next video to go over question 3.